Hello Internet, my name is Quinn and this is Blondihacks. Alright, it's the second part on the boiler build and I need to face the ends of the shell. And that seems like a straightforward thing, but it turns out holding a big pipe in a small lathe is not that easy to do, so I need to make a fixture. So let's go. I've gathered all my materials and the first chips I want to make are to face the ends of the boiler shell. That means I need a way to hold the end of it in the tailstock, which turns out to be a little tricky because it's, well, very large, much too large for my steady rest, but I need a way to support it that gives me access to the entire edge. So that means some kind of expanding mandrel in the center probably. And on my last boiler, I tried this with a plastic 3D printed one, and this honestly just didn't work at all. The plastic wasn't strong enough. So I liked the flexure idea though, so I thought I'd try something like that again in aluminum. I've got a scrap of aluminum here and I'm going to do a little test. I put a hole in the center for tapping and I'm putting a relief hole at the other end. Now this is an old model engineer's trick. You use the tapered end of a taper tap to create a tapered thread in the hole. You just thread the hole partially. You don't thread it all the way through and you get a little tapered thread in the bottom for free, and then you can thread a bolt into that and you can create an adjustable expansion joint that way. I've never tried this, but I think I'm going to give it a shot. So I've got my slitting saw here in the mill now and I'm going to slit this. Now the idea was I would slit it from the other end through the threaded hole into the relief hole, and well, I didn't realize that I was slitting this from the wrong end. But that's okay, this is still going to work for my little test. Right around here is where I realized I'd cut the slit from the wrong side. Okay, not really, I realized it halfway through the cut, but you know, at that point it was too late, so I pressed on. So now I'm going to put it in the vise here kind of loosely, and I'm tightening some threaded rod in there just to see if I can get it to expand along that flexible joint. The joint is expanding, but it's not really getting tight. It's easier to show why if I show it vertically, so you can see how it gets tight at the far end, which frankly makes sense because there's only one hinge point, and so it's really only going to create contact points at the far edges. You could do two of these joints, one from each side, which would give you a linear expansion, but aluminum is not a great choice for a flexure anyway because it deforms plastically. It's not really very springy. So I'm going to do this a different way, but that was a constructive test. To start with, I need to know how big my mandrel needs to be, so I got to deburr it, and I'm going to do some measuring here. And I did a bunch of measuring different ways because it wasn't clear how round this pipe is and how concentric it is all the way down its length, and the answer is not very. It looks like it's at least 10 or 15 thou out of round, which, you know, is about what you expect for water pipe. It's not high precision stock. To make my mandrel, I've got a very nice giant slug of aluminum here, and this is going to be just the ticket. So what I'm going to do is I'm going to make a disc that can fit inside that pipe. So I'm going to go over to my forejaw here with the outside jaws on there, and this is quite a slug for my little lathe. It's a little bit intimidating, but I'm going to do my best to dial it in here. There's so much mass hanging off the ends of these jaws that it's making me a little uncomfortable, so I'm going to put tail support in there. It may not be necessary, but it's going to make me feel better, so I'll go ahead and center drill this, and I'm so paranoid about it that I've got a board down there in case this slips out of the jaws. I don't want it to bang into the ways. And this is just aluminum, but still, it's pretty heavy. This is a big chunk. In fact, it's quite a bit too big, so I have two goals for making this disc from this slug. I want to minimize loss of material, and I want to minimize the mess that I make. I don't want to turn a whole huge chunk of this thing into chips. So here's how I'm going to do it. I'll start by facing the end, as is tradition. And of course I have the tailstock in there, but that's okay. I can just face all the way down to close to the center there, and that center area is going to get drilled out here anyway because I'm going to have a hole in the middle of this thing. With that faced down, I'm going to blue it up now and mark out the rough OD that I want for this disc. The reason that I'm doing this is instead of turning down all of this diameter, turning all that material into chips, I'm going to trepan it out of this stock because I only need a cookie that's 1/2 inch thick and quite a bit smaller diameter, so I think this is a good use case for trepanning. This made a terrible screech, so I'm going to switch the lathe over to Ocean Sounds for your benefit. I definitely had the earplugs in for this operation. This was working well, but at about half the depth I needed, it just wouldn't clear chips anymore. Maybe if I had flood coolant it would be better, but I just could not keep it from jamming up in there. So I decided to pause here and go ahead and part off one ring, and that will give me clearance again to continue with the trepan. You can see the lathe really threatening to stall there on the parting blade. This is really the maximum diameter that this lathe should be turning stock at. With that ring out of the way, I can go back in now with the trepanning tool, and I've got clearance for my chips again so they don't get jammed up in the slot there. Once I'm at full depth, I can come back in with the parting blade, and boom. Yeah, remember how I said I was right at the limit of this lathe? Well, that's one blown fuse, and it won't be the last before this project is done. These little lathes really hit the wall on power with large diameters like this because you have to run at low RPM so that the surface speed is right for a large diameter, but at low RPM these little DC motors really struggle to hold torque and they're dissipating a lot of current, and so that's when you start blowing fuses and overheating things. That method was very quick, but I think I failed at my goal of keeping the lathe clean while doing this. I think it's a little cleaner than if I'd just turned all that down, but yeah, it still looks like metallic ore that God of Machining threw up on my lathe. Now I can come back in and do some finishing cuts to bring that diameter down to the exact right size. I trepanned that a little oversized just because I didn't trust myself to nail that dimension. And here's the other reason I wanted to avoid doing this with turning, because turning aluminum is super annoying. Okay, finishing pass here, and then I'm going to put a chamfer on that edge so it doesn't interfere with the test fit that I'm about to do. I'm aiming for a very close fit on the copper pipe, but that's tricky because the copper pipe isn't very round. So I did my best on this, and that is just a little snug still. It won't quite go in there, so I took one more very light cut. And again, because the pipe isn't really round, you can't really get the fit that I was looking for with this. I think if I was going to do this over, I would actually see how out of round the pipe is first and then put it in the vise and squish it to be a little closer to round before doing any of this. Ultimately, I'm going to need to do that anyway probably to get a good fit on the tube plates, but that's a problem for future Quinn. The second cut was about as light as I could go, and now the pipe fits on there, but now it's actually a little looser than I was hoping for, but I think it'll still work. That close fit is important because, as I'm sure you figured out, I'm making an expanding mandrel here, but the way it expands is going to be sensitive to that clearance. So I'll explain that here in a moment. But now I can drill out the center. The reason I'm drilling out the center is because this mandrel is not going to run on the live center in the lathe. It's going to have a bushing in it, and it's going to run on a stub shaft. The reason that I'm doing that is because I don't want the tailstock to apply inward pressure on this mandrel. It's going to be held in the pipe by its own expansion forces, and if the tailstock is pushing inward on that, it's just going to push it into the pipe further, and the mandrel is going to tend to loosen over time, and I don't want that. So this is going to just be self-supporting in the tailstock end, and the tailstock is just going to be running in a bearing. You'll see how that works in a moment, but I drilled out the worst of it, and now I'm finishing out the size with the boring bar here. The dimension of this is not super critical, but a little deburr here, and now this part is basically done for what we can do on the lathe. It's too big to part off of this slug, but what I can do is get myself a little starting groove here. And then I'm going to take it out, and I'm going to take it over to the bandsaw, and that starting groove gives me a nice little groove for the saw blade to run in. And that little groove will make sure that the blade cuts straight and doesn't wander into my part, thus ruining it. just out of frame there, you can see I'm holding a bucket to catch the part in so it doesn't land on the floor and get dinged up. Also notable here is that the saw bottomed out on the part before reaching the automatic stop, so this is actually too big for the saw as well. It's a little bit dangerous, so be careful. Don't ever assume that the blade is going to shut off at the bottom. I think I did well on my other stated goal of preserving as much of this material as possible. That trepanning and parting method worked really well for getting a small cookie out of this big slug, and that will all go back into the stockpile. Now I can put this disc back into the lathe facing the other way, and I can face down the back side there. So you can see that the saw cut left it intentionally a little large, and then I'll just face that down. I got some copper shims in there to protect the finished surface, and I'll tap that against the jaws to try and keep things parallel here. And I dialed it in using the center bore there because the outside edge is a little bit hard to access, but either way it would have worked just fine. This isn't super critical because I'm just facing, but it's nice if it's running true. One of my better eBay purchases on tooling is a set of interchangeable indicator tips, like you saw that bent one that I was using there that lets me get inside a bore. I bought a set of broken indicators that was really cheap, and I bought it just because it included a great big pile of tips that were all sorts of interesting shapes and sizes. Boy, did that turn out to be a good idea. I'll chamfer the edge here as well, and that thunking you can hear is me chamfering the edge of one of my copper shims at the same time. Okay, that's looking good. So I'm now ready to, well, fish all those shims out of the chip tray, and then I'll be ready to make the bushing that goes in the center of that. To make the bushing, I found this chunk of bearing bronze in the junk pile. Bronze is cool because you can buy these hollow tubes like this that are designed specifically for making bearings and bushings because they know you're going to drill out the middle anyway, so why pay for those atoms? After facing the end, I just don't move the carriage and I set an indicator on it because I know the tool is exactly on the end of the part in that moment, and then I can use the indicator to measure the length of the part as I turn down the sides here. And now I'm taking my time because I want to get this fit really, really good on that bore that we made. I'm aiming for about a half thou interference here. Essentially a locational transition fit, which if you watched my video on fits and tolerances, you know what that is. Do a test fit here, and yeah, that feels like it kind of almost wants to start, but it won't quite go on, so that's perfect. That's the feel I'm looking for. That's basically a light press fit. Now I'm going to part it off. And you might think, hey, I never machined the center of that. Well, I'm going to press it into the disc first because pressing bushings in has a tendency to shrink them, and so you wouldn't want to machine the center before you press it in. So over to the arbor press. Got some Loctite 603 on there, which is the press fit Loctite, and I'll just line up my bushing there, put some scrap on top of that to press it in with, and down we go. It was a little looser than I wanted actually. That kind of snapped in there once the pressure got on, but it's in there, it'll work. So that is looking pretty good. Back into the lathe and dialing it in again. So this time I do have to dial in on the OD, of course, because the ID of that bronze bushing is still the rough core that comes with the stock. And I'm also checking the front here to make sure that it's set up parallel. And now I can bore that out to the inner dimension that we need. And this will ensure that the bore is very concentric to the outer diameter of the mandrel there. This is a really critical dimension. I need a smooth running fit there, about a 1 thou clearance. And that looks good. So out comes the disc. And this time I caught all 4 shims like a boss. Okay, now I've got a scrap of steel round bar here, and I'm going to make the stub shaft that's going to ride in that bushing. And so I'm going to start by facing off the end, as is tradition. I'll punch a number 2 center in there for some tail support, and turn down the OD. Now you'll note that I switched to the 3-jaw here just because it's quicker and easier for this, but concentricity is really important with this shaft, and there's potentially multiple setups here, so the 3-jaw would not be a good choice. However, I'm going to do some little tricks here so that I can make this entire shaft in one setup, and thus the 3-jaw will work perfectly. This little end here goes in the Jacob's chuck in the tailstock, so as long as it's smaller than the capacity of the chuck, that's fine. Now, I'm going to make a little shoulder on this, and then the rest of this length is going to be the stub that actually goes into the bearing. Now the shoulder is so that I can use a center on this if I want to. The center will be able to push against the mandrel because the shoulder will hold the stub shaft in place. The stub shaft area I turned down by using a grooving tool to create clearance, which allows me to get the turning tool started and then turn the rest of the diameter. And then I finished it up with a grooving tool, moving that sideways for a nice finish. And that allowed me to get in behind both sides of the shoulder and do this whole part in one setup. And then I just part that off and we are done. And Yahtzee. And here you can see how the pieces fit together. The little stub shaft goes in the bearing there. So the shoulder allows the tailstock to push on the mandrel if needed, but otherwise it just runs freely. Here's a better look at the fit in the pipe. You can see that it's a nice close fit on one axis, but the other axis is a little loose. You can see a gap there. So I got as close as I could, being that the pipe is not very round. Okay, this next step is almost physically painful for me. I have to put this beautiful part that I put all this time machining into the bandsaw and cut a big chunk off of it. I won't lie, this scared the crap out of me because, well, I didn't know yet if this whole idea was going to work, so maybe I just ruined a couple hours worth of work. But it's over to the mill now, and I'm going to set this up and put some features on that flat side. Now that bandsaw cuts really nice, so I just set it up using the indicator right on that flat surface there. I didn't bother machining the saw cut here. And I'm centering this up with the edge finder. Now on the y-axis that's easy. On the x-axis, because we're on the top surface of the curve there, I have to keep the edge finder at the same height and go all the way around. And that way I'm edge finding on the chord of the circle, and so my center will be valid. It's important that my reference for these features be the center because I'm going to make matching features on that other piece that we cut off, and those features have to line up, including the gap of the circle that no longer exists because it was the bandsaw curve. So you can see the math here could be a little tricky. So using the center as the reference for all of this makes that easy. So I drilled and tapped holes and put some threaded rod in those holes. And now I'm just measuring how much clearance I'm going to need to get a wrench on those nuts. So now you see what I'm doing. I'm creating an expanding mandrel with nuts that are going to be used to spread the halves apart. So with that area marked out, I can now machine down little square areas here around each of those threaded holes, and that's going to create clearance for the wrench. Just double check that my thickness is good, and that looks good. So now I can go ahead and finish that out to width, and then do the same thing on the other side there with the other threaded hole. Okay, so that part's basically done. Now for the top half, same thing. I'm going to edge find on this, but we're below the curve now, so no need to do any chord tricks. And these holes are just clearance for the tops of the threaded rods there. So they need to be close fitting to keep things aligned, but not tight. And here is the final expanding mandrel assembly. And now you see why the close clearance was really critical, because the expansion of this mandrel all happens on one side of center. So that does mean this mandrel is going to introduce a little bit of runout, but the runout will be half of whatever the clearance was between the unexpanded mandrel and the pipe. So it shouldn't be more than a few thousandths. Okay, moment of truth time. Stub shaft goes in the Jacob's chuck on the tailstock. I still don't really know if this is going to work, so this is pretty exciting. The near end is fixtured by expanding the jaws of the 3-jaw to hold the inside of the pipe there. And I'll put some whey oil on the stub shaft there and slide that into the bearing. And let's see if this thing runs very well or not. Well, it's turning okay, so let's give it a little juice and see what happens. I spun it up slowly at first because if I'm going to die, I'd like to have a little warning. And that's looking good, a little more speed, and yeah, it's running pretty well. There's obviously some run out there in the end, but because I'm just facing it, that's going to be fine. There's more run out than I expected, and we'll investigate that here in a moment, but since I have this nice setup, I decided I might as well polish up the pipe a little bit. The pipe had this weird patina, and it almost looked like corrosion on the outside of it that I couldn't identify. You can see the weird color, and there's also some pitting, some surface texture there that I have not seen before in pipe that I've bought, so I'm not sure what is going on there, but it looks much better now. Look what I noticed after cleaning it up. This is type L pipe. You may recall from the first video in this series that I specifically bought type M. So yeah, look at that. Sometimes you get more than what you pay for. The wall thickness on type L is quite a bit larger than type M at this diameter. So I got a bunch of free copper. With type M pipe, the boiler shell already had a 16,000% safety margin, so now it's even better. A couple hours of yak shaving and it's all down to this. Can I face the end of this pipe or not? Got a sharp-nosed turning tool in there. I'm winding from the inside out so that I can use a regular right-hand turning tool. And that is cutting really, really well. Finish is great. There was no chatter, no drama at all. That is, wow, that's exactly what I was hoping for. And yeah, that edge was razor sharp and I cut myself on it. So I'll just go ahead and chamfer that now. Now let's take another look at that run out because it was higher than I expected. You can see there's quite a bit here even after machining, so it's not just the forward and back motion creating an optical illusion there. And you can see if you look closely that the tailstock is vibrating slightly. So I put an indicator on there and you can see that it's quite round except for one spot that's like running out about 20 thousandths. So, you know, it's within 4 thou and then, oh my God, 25 thou. So I think that's really what I'm seeing. It's just that one spot that's running out. And you can kind of see that if we go back to this shot where I was test fitting, you can see how it's pivoting on these 2 points here, and there's big gaps here and here. So this tube is just squished on that one axis. And it's also possible that when I put my expanding mandrel in there that I may have also exacerbated that, because I think the run out was actually in line with my mandrel a little bit as well. But to be clear, I didn't tighten my mandrel down that much because it doesn't need to be that tight, so I don't think I deformed the pipe with it. With one end faced, I can now cut it to length and prepare to face it to final length. So I've marked the rough dimension there. I'm going to cut that chunk off using my horizontal bandsaw. This saw cuts nice and straight. This would be a very quick, easy cut with a portable bandsaw or even a hacksaw, but I'm using the big saw here because this thing cuts really straight and I'm not going to risk getting into the material that I need to save. I'm using WD-40 as a cutting lubricant there. Seems to work fine on copper. Now it's funny how sometimes even tools you make yourself have a learning curve on them. I found that if I put the mandrel on the tailstock first and then slide the pipe over it like this, I get quite a bit less run out because this ensures that at least the mandrel is well aligned with the tailstock and then the pipe is forced to shift to wherever the mandrel lands. And that generated better results. So I tighten it in place and now it's hard to tell because there's a rough saw cut on there, but it's actually running out quite a bit less than it was before. And you can also see that the tailstock is no longer vibrating there. So that's quite a big improvement there. So I face this off the same way down to the precise length I hope that is specified in the drawing. Here's a wider view here where you can see there's still quite a bit of run out because as you saw earlier this pipe is squished 20 thou out of round, but it's quite a bit less than it was, so you know, learning curve on this mandrel a little bit there. There is my pipe faced all the way down. Now to see how I did on length, I bought a special new tool thanks to the Patreon kitty. This is a 12-inch caliper and yeah, it just goes on and on. I'm aiming for 9-inch 138 on the final length here. And I measured in a couple of spots because I was seeing some puzzling numbers. The length was varying more than I expected. So I tried measuring a different way here. I set it up on the surface plate and just rotated it under an indicator here. I know that one side is more square than the other. One side has a little bit of a rock in it and the other side does not. So I put the better side down on the surface plate and then measured it with the indicator here. So the caliper was showing about 11 thou of variation in length and the surface plate is showing about 5 thou. So I tried a third method, which was to put it back in the lathe and I check with a light to make sure it's squared up against the chuck face. And then I put an indicator on the other end and this is showing less than 1 thou. So 3 different measuring methods, 3 very different numbers. It's hard to know the truth. It's probably somewhere in the middle. I've probably got about 5 thou of variation in the length there. So that's variation in the parallelism of the ends of the pipe. So that's not as good as I was hoping for, but to be clear, it's orders of magnitude better than a boiler shell needs. You could honestly just file this thing until it looked nice and you'd be fine. Even a rough saw cut would be fine. This entire exercise was really just a challenge I set myself to see if I could face the ends of this pipe, but the mandrel that I built is also going to be very, very useful in upcoming operations on this shell, so that's why I put all this effort into it. So now I can put the shell next to the engine here just to give you a sense of what this is going to look like scale-wise. The shell includes the firebox, so this is the full height of the final boiler except for the chimney, which will be on top. So this is a great start on this boiler. I hope you've enjoyed this so far. Thank you very much for watching. And maybe throw me a little love on Patreon. There's a card there on the screen and a link down below. Thanks for watching, and I'll see you next time.